Hi, my name is Rachel Snyder, and today I'm going to be talking about integration by parts. So I'd like to ask you what you would do if I were to ask you to integrate the function x sine x dx. So I'll let you pause the video here and think about it if you'd like to. Now, if you did pause the video, maybe you tried just normally integrating it or integrating it using substitution, but what you probably found is that neither of those worked. So the reason why that is because this function requires you to use a special new technique called integration by parts. So in order to get us thinking about integration by parts, I first want to take us back to calculus. So say we have the function uv, where u and v are both functions. If we want to derive uv, then we're going to get u derivative of v plus v times the derivative of u. Now, if we were to integrate both sides of this equation, we'd have uv, because the integral of a derivative is just the function, equals the integral of u dv plus v du, which we know we can simplify to be the integral of u dv plus the integral of v du. So that tells us if we have a function of the form integral of u dv for some u and v, it's going to be equal to uv minus the integral of v du. So let's see if we can get our function into this form and what our u and v would be. So just like when we're doing integration by parts, by substitution, our first step is to figure out what our u would be. And this case, we're also going to have a v that we need to figure out. So one of the important things is we want our u to get simpler when we derive it. So for example, if we were to say u equals sine x, the derivative of sine x would just be cosine x, and that's no easier to derive. So, or to integrate. So let's try u equals x. Then du would equal 1. Then we can see that the entire function we're integrating is u times dv. So rather than finding v next, we're going to find dv next, and it's just going to be our original function divided by whatever we decided our u was. So in this case, our dv is going to be sine x, and the antiderivative of sine x is just cosine x, negative cosine x. So let's try plugging this u and v and du and dv into this function. That would tell us, oh, dv is sine x dx because we're integrating it. Very important. And 1 dx as well. So that would mean that we'd have the integral of x sine x dx equals x times negative cosine x minus the integral of negative cosine x times 1 dx. So simplifying that, we can see that this is equal to negative x cosine x plus the integral of cosine x dx. Then we know that the integral of cosine x is just going to be sine x. So then we can see that this would be equal to negative x cosine x plus sine x. And don't forget your plus c. So we have found our answer. And lots of similar problems use similar integration by parts. And if you just follow these same steps that we used, you can find your solution the same way. Thank you.